What's up, guys? In the last video we covered functions. Today I'll be covering recursive functions. Now, a recursive function is a function that calls itself within its own definitions. For example, I could do something like this: define add, right, x, y, and I could return x plus y, right? And I can print add x and y. See, as we are calling the function over here, we need to give in values for x and y. In this case, 5 and 6. We should get 11 because we're printing it out, right? But what if anytime I call it within itself, um, that is a recursive function. So if I try to do something like this, I'm basically doing this while adding itself. So this actually, you cannot do this. You can't just return the value itself. You need to do something with the adding, right? So in that case, say if I had x equals 2, then I would return x plus y. Otherwise, I could return um, the x and y like that, right? And as you can see, it doesn't really work for this function, right? Because there's no need to add something within itself for that many times. So doing this, calling itself this many times does not work unless you're doing it with a different value. So this wouldn't work here, right? But for example, say I wanted to find something like the Fibonacci sequence, right? So a math thing where you start off with 0, right? And then you go to 1, 1, right? So basically what this says is starting from 0, every number after the sequence is going to be the sum of the last number. So 1, right? If you go from 0 to 1, there's no way it can become 1. So the way Fibonacci works is you start off with 0 and 1, but every number after is the sum. So you have 0, 1, and then the next number is not 2. That would just be in succession, right? The number after 1 is 2. But in this case, every number after 0 and 1 is going to be the sum of the last numbers. So what's the sum of the last numbers? 0 plus 1 is 1, right? And then what happens here? 1 plus 1 is 2. 2 plus 1 is 3. 3 plus 2 is 5. 5 plus 3 is 8. 8 plus 5 is 9, 10, 11, 12, 13. It's 13, etc., right? So notice here that all of these numbers follow the rule of previous, etc. But these first two numbers are always going to be the same. They're going to be 0 and 1. So how would we do something like that? Well, using a function, we can define Fibonacci, and we can give in the parameter n. Now, this is which number in the sequence, right? Do I want to get the first number or the 100th number in the sequence? So basically, this will be able to tell us, calculate the Fibonacci of any number n. In this case, we're going to check if n is equal to 0 or n is equal to 1. And in that case, we're just going to return n. So it's basically like the print function, but it's just returning the value itself. So if it's 0 or 1, just return the function. So we're not doing anything with it except returning it. Otherwise, right, if it's not 0 and 1, what do we say it is? We said it's the sum of the last numbers. So we're going to return the sum of the last two numbers, which is going to be Cn minus 2, right? So what this does is we're going to call this function, right? During this function being called n, if it's not 0 or 1, say it's 2, what we're going to do is we're going to return this function over here where we plug in 2 minus 1, which is 1, and then 2 minus 2, which is 0. So what this is going to do is it's going to repeatedly call the same function and give you the sum of the last two numbers, which is n minus 1 is the previous number, n minus 2 is two numbers before the current number. Okay, so this is how we check for one of the cases, and then this is how we use the function itself to calculate the rest. So now we can print the Fibonacci of 5, right? And this can just go on forever. It's 5, right? Let's say 10. It's not going to be equal to 10. It's going to be equal to 55. And we can verify this. We can search up Fibonacci of 55. Okay. And what is this? So you can search up this up. Okay, it's not the 55th number. It's the 10th number. My bad. Fibonacci of 10 is clearly 55. So that means this thing works. But with that said, that's how recursive functions work. I will see you guys next one. Now, one thing is that recursive functions, they're used for patterns. So basically, if I had like a shape and I was able to zoom in infinitely and see the same shape but in a different size. That's what recursive function is for. It's for repeated behavior that's different, right? You notice this is repeated, right? But this is for these two cases. If it's this or this, it's going to be this. So it's basically I want to repeat something, but I also want to have it change, right? In this case, n will change, but the same thing, same kind of behavior will happen. It's like a pattern. It's for patterns. So I'll see you guys in the next one. Bye.